Welcome to the deep dive. Today we're going back to the 17th century for a deep dive into a forgotten masterpiece. It's really just a simple piece of wood and brass, but it changed everything for science and engineering for, what, 350 years? We're talking about the slide rule.
It's so easy to forget just how painfully slow math used to be. I mean, you're in the 17th century. It's the peak of the scientific revolution, astronomy, navigation.
All these huge new fields opening up.
Exactly. But doing the basic math, multiplication, roots, division, it was tedious, and you were almost guaranteed to make mistakes. John Napier, the guy who invented logarithms, actually complained that it was the most frustrating part of his work.
And his logarithms in 1614 were a huge step, but you still had to carry around these massive heavy books of tables, right?
And then you get Edmund Gunter in 1620, who brilliantly puts those tables onto a single ruler, the Gunter scale. But you still had this clumsy two-handed process with a compass.
So you're physically measuring lengths on the scale with a compass to do the math.
You are. So you have this incredible principal logarithms, turning multiplication into simple addition, but it's not fast. And it's certainly not portable. And that's where William Oughtred comes in. He delivered the killer app, basically, the slide rule itself.
Okay, let's get into that technical evolution. Oughtred has this aha moment around 1622. He's a vicar, an academic, and he just thinks, why use a compass at all?
Why not just use two rulers?
Exactly. Just put two Gunter scales next to each other and slide one along the other. That physical movement adds the lengths, the logarithms together, and boom, multiplication just becomes sliding a piece of wood.
And that one simple idea solves the two biggest problems: speed and portability. It's genius.
But his first design wasn't straight, was it?
No, and that's what's so fascinating. When he finally published it in 1632, The Circles of Proportion, it was circular. And that wasn't just for looks, it was a really clever technical fix.
A fix for what?
For calculations literally running off the end of a straight ruler. If your answer was off the scale, you were stuck. But a circle is continuous. It never runs out.
Ah, all right. So Oughtred nails the core concept, but it took a few more upgrades to get to the slide rule we might recognize today.
Oh, absolutely. The first big one was in 1654. Robert Bissiker adds the tongue and groove design. That's the slide that sits inside the body. It just made it stable.
And then the cursor, that little sliding window with the hairline.
That was the real game changer. Amédée Mannheim, a French officer, standardized the scales and added that moving cursor around 1850. That's what finally allowed for really fast, really precise, and repeatable calculations.
So let's talk about the impact on society. This thing basically powers the Industrial Revolution.
It's the engine behind the engine. James Watt was famously using specialized slide rules to perfect his steam engine designs. Fast forward to the 20th century, and you have scientists using them to calculate trajectories for V2 rockets.
And even for the Manhattan Project.
Yes, performing the critical math for the atomic bomb. For 350 years, this was the computational backbone of modern progress. It's just incredible to think about. The Golden Gate Bridge, the F-16 fighter jet. Even the Apollo astronauts had them.
They did. They carried them as a backup for emergency calculations, just in case the computers failed.
Wow.
And, there was a huge educational impact, too. A slide rule only gives you the digits. It doesn't place the decimal point. So engineering students had to get incredibly good at estimation.
You had to actually understand the magnitude of the number you were looking for.
You had to. It trained a whole different kind of mathematical thinking. You couldn't just blindly trust the machine.
Which brings us to the great irony of it all.
Yeah.
The end of the slide rule.
It's a great story. The first big electronic calculator, the Friden 130 in 1963, was designed
Using a slide rule.
reportedly, yes, entirely with a Kofel and Esser slide rule. But once the pocket-sized HP 35 came out in 1972, they even called it an electronic slide rule, it was over. By 1975, they'd all but stopped making them.
Just like that.
It really is a powerful symbol of intellectual effort, though, of analog computation. It proved that sometimes the most difficult problems can be solved just by measuring simple distances.
So a final thought for you to take away. Oughtred's amazing technical leap, that idea of using sliding scales for math, it's not entirely gone. If you look closely to the bezel on some modern pilot's watches or chronographs, what do you see?
A circular slide rule.
Exactly. His logarithmic principles are still there, hiding in plain sight on your wrist. If you want to see just how complex these devices got, you should look up the International Slide Rule Museum online. It's pretty amazing.